Hi, my name is Andrii Matviienko from Technical University of Darmstadt, Germany. I'm going to present our work titled Quantified Cycling Safety towards a mobile sensing platform to understand perceived safety of cyclists. This work was conducted together with my colleagues Florian from Hasselt University, Belgium, and Bastian Pfleging from Eindhoven University of Technology in Netherlands. Cycling safety is typically reflected in accident reports submitted by police, or it is assessed based on cyclists' subjective responses. Although the later one provides data without necessarily encountering an accident and the former one reports a dangerous situation post hoc, both of them rely on subjective assessments of the involved context and parties, such as police staff and officers, cyclists and other road users. In our work, we go beyond these established methods by exploring quantified cyclist data resources. For example, psychological data, physiological data, and body movement, to better understand the perceived safety of cyclists with the goal to improve traffic safety. Previous researchers designed cyclist assistance systems that primarily focus on the data provided from external sources such as other road users broadcasting their positions and velocity using vehicle-to-X technology, for example car-to-X, or from internal sources such as physiological data from sensors placed on the cyclist's body or on the bicycle itself. This separation between the external and internal sources based on the existing methods of data collection assisted us in defining two dimensions in the proposed taxonomy for assessing cyclist safety. So by comparing prior work on perceived cycling safety, we identified two dimensions along which existing approaches can be assessed. These complementary dimensions form our taxonomy of methods to assess cyclist safety. The first one is data source, can be internal or external, and the second one, type of measurement, can be objective or subjective. The first dimension, data source, is split into internal, for example body movements or physiological data, and external data sources, for example traffic cameras, car sensing, and other infrastructure data sources. The second dimension, type of measurement or measurement, covers subjective and objective aspects of the data is measured and assessed. The subjective part includes sources with cyclists, road users, or police officers' subjective estimations, while objective methods rely on the quantitative assessment of input data from the sensors. In this work, we looked at earballs as earbuds that do not only provide audio output, but also deliver rich sensor input from an inertial measurement unit. In cycling context, such variables will allow collecting sensor data to measure the amount of relative head rotation as an indicator how much a cyclist looks around. When using earballs with an integrated 9 degrees of freedom AMU that returns absolute orientation, we can measure the difference between the smartphone in the pocket of the cyclist as a reference for the driving direction of the earbuds. This will help to determine in which direction the cyclist looked, eventually getting an indication which potential elements of interest, for example approaching cars or pedestrians, require additional attention. We derived 5 use cases based on the accident reports that we considered as challenging for cyclists in terms of decision making and which might require measures to improve perceived safety. While situations street entering and unprotected turn are considered the most dangerous ones for cyclists based on accident reports, we also consider situations such as protected left turn, obstacles, and lane change, which include a comparable level of difficulty but are typically missed in statistical reports. Following the proposed taxonomy and proposed crowdsourcing approach, we plan to implement a prototype and run a series of experiments with cyclists to test our concept and assess our hypotheses related to the correlation between head movements and perceived road safety. This work will showcase one possible technical solution of collecting internal data about cyclists from an objective perspective, with future development of car-to-X technology. We envision not only receiving safety-relevant information from other vehicles and infrastructure, but also sending the cyclist state and behavior to other road users as an additional safety indicator. That was Quantified Cycling Safety. Thank you for your attention.